Thereby, we were discussing the bond of the aggregate. Now, what is the bond of the aggregate? Is bonding of aggregate important? You don't need to have rocket science here. Cement is the binding material and aggregate is not the binding material. But aggregate should bind with the cement. They should bind with cement. There should be a bond with cement. So there should be a adhesion between aggregate and the cement paste. Cement does it reacts with very less materials, but it binds with most of the materials. It binds with steel, it binds with aggregates. So most of the materials, they are bonded by cement, but aggregates have a good binding capacity with cement. So there is a good amount of adhesion force between aggregate and cement. Now this increases with the roughness, which I just told you. The roughness of aggregate, more is the roughness, more is the binding with cement. Or if you have smoother, or conversely, if you have smoother aggregates, then there will be less amount of binding with the cement. Now it also depends on the size. Greater is the size of the particles of aggregate, it will not properly interlock between, there will not be proper interlock between the aggregates, and there will be no proper then binding with the cement as well. So the size should be somewhere average size for the aggregates. Then comes the shape of the aggregate, and I told you angular size of aggregate or the irregular size would be good, but irregular size you could get the flaky particles a lot as well there. Thereby, we usually prefer the angular size of aggregates rather than the regular size of particles. So the binding with the angular size is best of the aggregate with the cement. Angular size of the aggregate, that binds best with the cement. So coming to the strength of aggregates. So the strength of the aggregate is the crushing value of aggregate Now the crushing value or the crushing strength of the aggregate is 200 megapascals. So that's quite large as compared to cement. Cement overall, along with concrete, cement would have a 43, which I discussed last time, megapascal to 53 megapascals. Even the lower side crushing value of the aggregate, this is the upper value 200. सबसे कम aggregate की strength भी 80 megapascals अच्छी खासी होगी. So that's quite large as compared to cement. So this is the crushing value of the aggregate. And how is it determined? It's determined by a test which is done in aggregate crushing value test. This one I'll show you. This is the aggregate crushing strength test that's performed. There is a cylinder in which the aggregates are filled, and then an impact plunger is dropped onto it, and it's checked how much do the aggregates, once the plunger is dropped onto it, it's checked how much do the aggregates they get crushed, how much do they actually compress under the action of this. So, and there are a number of impacts given onto the aggregates. So you get from the number of impacts, you actually get and from the height of the plunger you get the crushing value. So again, given in the IS code, then how to perform this test. So then comes the porosity of aggregates. Now, what is the porosity of aggregate? It is actually how much percentage of pores are there. It's percentage pores within the aggregate. How do you determine this? The easiest way to determine this is through the permeability and absorption tests. What is done is that aggregates will have an aggregate will have pores. A single aggregate would have pores. Now those pores would absorb water. So under a pressure, you fill up a sample with water, and the pressure is applied, and thereby you're getting the amount of water that has gone into the pores, how many pores have been filled up. So absorption test is much simpler. You just keep the aggregates within the water, and then you check for its moisture content by taking it into the oven. So you check the mass before and you check the mass after you have put it in water. तो पहले पानी में डालते हैं, then you take it in the oven, and then कितना मास कम हो गया तो it will tell you कितना पानी इसमें already था. So it's the absorption test or the moisture content test in the aggregates. So what is the porosity that different stones have? Gritstone has 0 to 48% porosity. Quartzite has 1.9 to 15.1%. Then you have limestone. This is 0 to 37.6%. And then you have granite. This is 0.4 to 3.8%. So you'll see that granite has the least porosity, and it's thereby the best material in terms of the strength as well. In terms of long-term durability as well, granite is good. You use your granite stone in your kitchen counters where you uh, have water all the time on the kitchen counters, and but still it does not degrade. That stone does not degrade even with water because the porosity of that stone is less. So water is not going within that stone. On the other hand, the sedimentary stones like the limestone, you have or the gritstone, you have a large amount of porosity. So that can not be used completely, but limestone is a good material to be used within the concrete, and it's cheaper material. You cannot use granite within the concrete. So usually we use limestone or siliceous rocks as the aggregate material. The concrete, the reason being they are cheaper, and there is a covering of cement over the aggregates at most of the times. Thereby, even if they have large amount of porosity, still being cheaper, we use them. Otherwise, we would have gone with even with the basalt rock, which is a lesser porosity, and that stone is even greater in strength, but it would make a very uh, costly concrete. a basalt rock or a granite rock, that would make basalt rock is black in color. Somewhat like this. Yeah, the basalt rock. This is the basalt rock. So these types of rocks, if they are quite costly, they have less porosity, greater strength, but you cannot use them in ordinary concrete because they will give you that will make the structure very costly. So finally, coming to the gradation of aggregates, how do we get to the gradation of aggregate? Now, what is the gradation of aggregate? First of all, I just told you a term, graded aggregate. Gradation means from top size till bottom size, what are the various grades? What are the various grades and their percentage? In simple terms, this is what it means. इसका मतलब ये है, आपके पास फॉर एग्जांपल सैंड है 2.36 mm size, maximum size है, and the lower size is 60 microns. Now in between these will not be the only sizes. 2.36 is the top size and 60 micron is the lower size. In between these two, there will be many sizes. There is a size of 1.18 mm. There is a size of 750 microns. There's a size of 150 microns. So even less than this, 0.4 mm. And there are sizes in between these as well. This is for sand or the fine aggregate. You have 2.36 till 60 microns. The lowest one is 60 micron at the bottom. So what do? We grade it on sieves. How do we do that? We have different sizes of sieves. These are the different sizes of sieves. They have a lid at the top, and then at the bottom you have a span. So there no goes through. And then there are different sizes. 4.75 is for sand, 2.36 below it, again sand, 4.75, whatever is retained is coarse aggregate. 2.36 classifies as the sand. 2.36 classifies as sand, 1.18 below it, 600 also, 300. There is 750, which I discussed, that's also there. So 600, 300, 150, and then you have a pan. And pan would be 60 microns से भी नीचे जो 0 micron भी होगा, it would retain even that. There is no 0 micron sand that would be available, but it would retain all other sizes below 150 microns. So you actually check from 2.36 till 1 pan तक कितना वजन हर सीव पे रहा और कितना आगे चला. So whatever is passing through, so from every, इस पे दिखाया गया है, there is a large amount of sample size here. It goes on decreasing because more and more mass is being retained on individual sieves. Thereby, at the end, the least amount of the mass will be retained. So you actually check what is the weight retained on 2.36, what is weight retained on 1.18, then on 700 or 600, then on 300, We can even skip 300 and then 150 and pan. So these masses, they are very important because they will tell you, they will give you an idea like this. Uh, you have a graph between which is passing, the weight that's passing. This is weight. This axis tells you the weight in kgs, for example, or grams. That's passing through each sieve. And this is sieve size in mm or in microns, whatever you want to keep it. Then the greater the sieve size, for example, this is 2.36 at the end mm, and here it is, for example, here this is 150 microns. In terms of mm, that would be 150 into 10 raised power minus 3 further. So then what is the weight that's passing through here? That's very important. So weight that's passing here would be somewhere here, this much, for example. Now the weight would keep on decreasing from with the decrease in the sieve size that's actually passing through. And what is retained would be conversely for this, which I just showed you from the figure. C is the most. So the graph would look somewhat like this, going towards the top. Now, if it's well graded, the graph would be straight like this. This is well graded graph. It would be a uniform graph, a linear, moreover a linear graph from. तो इसका ये मतलब है there are all sizes that are retained, there are all sizes that are passing. So it's a well graded mixture. But if you have a graph somewhat like this और बीच में कहीं पर ऐसे गैप आ रही है, so there is almost nothing passing between these. That means these sizes are not existing. These sizes are not then existing. These sizes are not existing. So this is a gap graded. This is gap graded. So this tells you that there is a gap. There are top sizes and there are bottom sizes. Beach wale sizes missing hai from the sand mixture. So, and the poorly graded would be, there would be sizes at the top or sizes at the bottom and very less sizes towards the lower sizes. So this is poorly graded one. So we require a well-graded composition. So whenever you get a sand, first of all, for you as an observer, what do you look at the sand? What is the color of the sand that you look for? Any one of you who wants to answer this?
Grayish.
Greenish, or if no. Deleterious material, that means इसमें कूड़ा करकट नहीं होना चाहिए. Now, if that is present within the sand, it's actually, it will not react. Its strength will be less. So it will not give the strength. Deleterious material will not, if it's organic deleterious material, it will start to degrade. So any kind of deleterious material within the sand is, or within the coarse aggregate, is not allowed. So what we do, और जो पहले कंस्ट्रक्शन होती थी, they used to sieve the sand and first like this. I'll be showing pictures. sieving of the sand is done like this. On a large sieve, they take out the big particles from this first, and then they just हाथ से उस पे because all the small particles which are not going through, they can take it out, but at the same time it is washed. If it, अगर यहाँ पर कोई पिक्चर है, so washing of sand after sieving is important. So the sand needs to be washed as well for any construction. So in a construction site, you are sieving the sand. Whatever sand you are getting, it should be actually washed. Similar is with the coarse aggregates with the gravel. More so in case of gravel, you require the washing to be proper in case of gravel. Not for that much for sand, but it has to be, gravel has to be washed. Now, how much do you see being followed here? This is the washing of the gravel being done. So it should be all जो इसमें मिट्टी के particles होंगे sticking with it and all that, they need to be taken care of. So washing is done even at the small scale level. Let me get a picture of that. So now